we are going to use these half-angle formulas, and I suppose it's a good time to remind you that angles are based on degrees and minutes and seconds, if you like, analogous to time, and you can philosophize about that later. But there's 30, so that's half, because there's 60 minutes in a whole angle. Okay, so that means, let's see, 67 and a half. If I have that twice, what is that? Well, 67 plus 67 is 134, and then I get my 135 out of it because these two halves. Okay, so what I can say is the sine of 135 divided by 2, which is the same thing, okay, is equal to the square root of 1 minus cosine, and here's the interesting part, I just take the top, not the 135 over, and 135 is way more manageable. You say, really? It's more manageable? Sure. It's a 45-degree angle in quadrant 2, which is way more manageable than, 67 degrees, 67 and a half degrees over here. Yes, it's better, way better, because I know how to deal with a 45-degree angle. Over 2, that's on the inside of the radical as well. So let's see, what is that? The cosine, I should have kept up my triangle. Maybe I'll draw it over here. So here it is in quadrant 2, 45 degrees. And let's see, it's 1 square root of 2. And this is negative. Okay, so it's going to be a negative. So what do we got? Let's see, we're going to have the square root of 1 minus the cosine is, we're going to change that to plus 1 over square root of 2 over 2. Okay, so let's see, what shall we say? 1, and while we're at it, let's go ahead and get common denominators. 2 plus square root of 2 over 2 over 2, which is equal to, we're going to multiply top and bottom by half. Let's see if I can make that clear. And we will get 2 plus the square root of 2 over 4. And let's see, can I clean that up anymore? I could take the 2 out, right? I could take the 4 out as a 2. So I could say the square root of 2 plus the square root of 2 all over 2. And I think I'd be happy with that. I'll just keep it like that. Okay, and then, if I want an estimation, I could use my calculator, but I want the exact answer. Because they said exact answer. So I better not use my calculator. Okay, so let's see. How about cosine? You look over here. Cosine is extremely similar, but cosine gives itself the plus. Okay, so it's the exact same thing, except, all right. So now we're going to say the cosine of 135 over 2 is equal to, pretty similar, 1 plus cosine of 135. And then we can kind of do some similar things here. We're going to say 1 minus, let's just jump ahead and say this. We know what's coming, right? Kind of, I mean, it's almost the same. So now I think we can just go ahead and say, you see how it went last time. It's going to be the same thing, only now it's going to be 2 plus the square root of 2. Wait, 2 minus, sorry. It was 2 plus last time. 2 minus the square root of 2, square root of that over 2. Okay? Since we knew what happened last time, we The only thing different is the sign. And I don't mean the sign. Yeah, you know what I mean. Okay. The tangent of 135 over 2. Well, let's see what we have. We have some choices. What do you think? I guess we could use this sign. So we'll say the sine of 135 over 1 plus the cosine of 135. All right, let's see where this goes. The sine of 135, by the way, no square root sign, just notice that. The sine of 135, well, that looks like 1 over the square root of 2, right? And on the bottom we have, we're going to say negative, because we know the cosine of 135 is in quadrant 2. So that's 1 over the square root of 2 down there. And we'll multiply everything by the square root of 2, I guess we could say that. And we'd say 1 over square root of 2 minus 1. It looks like we should probably get rid of that. We'll say this. And we will multiply by the conjugate. And that will give us square root of 2 plus 1 over 2 minus 1, I think. So the square root of 2 plus 1 over 1. So I might switch this around. There, I think that's my answer right there. And you should check this with a calculator just to see, is this a reasonable thing? Do I get this? You might want to change your calculator to away from radian mode, because now we're in degree. So we say 67.5. What's the sign of that? Well, it's 0.9. Okay, so then I say the square root of 2 added to 2, and then I take the square root again and I divide by 2, and it's the same thing. It's approximately equal to 0.92, we'll say 4. But that's not exact, so that's not our answer. But it does work. Just in case you're like, hey, did I do that right? How do I know if I did this right? Well, it's easy enough. What's the tangent of 67.5? Well, let's see. The tangent of it's 2.4. Is that the same thing as the square root of 2 plus 1? You bet. It's roughly equal to 2.414. I didn't put the point very good. But yeah, it's the same thing. So if you want to check your work, your calculator's right there. And they do give you the same thing, even though it looks quite different. Same thing.